Hi everyone, in this video we're going to go over some VCAA exam questions relating to sampling. So sampling is done in probability. So basically it's very similar to the rest of the probability questions you've done, but instead of looking at a whole group, we look at a sample within a population. So we tend to do these types of statistics when we look at when we want to look at a big population, but in doing so is too difficult. So if we wanted to look at, the travel habits of people over 60, then to interview everyone over 60 would just be too difficult. So you take a sample and that would be a representative sample of the population. All right, so let's get stuck into some questions. So a couple of questions for exam 1. Now, in 2020, sampling was not on the course. It was taken off the course because of the impact coronavirus had on the students. So you might see it in 2021. So it's probably a good idea to understand it, although if it is on there, it is such a small piece, okay? But you can get easy questions or you can get hard questions. So it's hard to tell what might be on this year's exam. Anyway, Fred owns a company that produces thousands of pegs each day. That's great, Fred. Okay, he randomly selects 41 pegs that are produced on one day and finds 8 faulty pegs. All right, so what is the proportion of faulty pegs in this sample? So the proportion of faulty pegs, and I keep going to say eggs. Okay, so we've got 8 that are faulty in a sample of 41. This is exam 1. Actually, we can't simplify that, but 8 out of 41 is fine. You don't need to convert that to a decimal or anything. You can't simplify it any further. All right, question B. Pegs are packed each day in boxes. Each box holds 12 pegs. Okay, so that's important. Let P hat be the random variable that represents the proportion of faulty pegs in a box. The actual proportion of faulty eggs produced by the company each day is 1/6. Okay, so it's not 8 out of 11, although you can see it's quite close to 1/6. We want to find the probability that this random variable, p hat, is less than 1/6. Okay, express your answer in the form a, b to the power of n, where a and b are positive rational numbers and n is a positive integer. Now, this question is a little bit harder. So we're actually going to be using the binomial theorem here. So the number of trials that we have is 12. The probability of success, so P, is 1/6, and that means the probability of failure is 5/6. Now we know the proportion of pegs that are faulty is 1/6, okay, so that's what we've got here. So we got to find out in our sample how many pegs is that going to be. So 1/6 times 12 is 2. So basically we want to know the probability that the number of pegs, which I'm going to call x, okay, so we're not looking at the population proportion anymore, we're looking at x, is less than 2. Now that is equal to the probability that x is equal to 0 plus the probability that x is equal to 1. Okay, so if we're looking at x is less than 2, then we want the probability that x is equal to 0 plus the probability that x is equal to 1. Now, with the binomial distribution, you would usually do it on your calculator, but here is an example of when you need to know how it works by hand. So x equals 0 is good. So that just means our probability of failure, which is 5/6, every peg is going to be fine. It's not defective. So remember, P is a probability that it is defective, and Q is a probability that it isn't defective. Okay, so we want X equals 0, so no defective pegs, 5 over 6 to the power of 12. Then we've got the probability that 1 is defective. So we're basically going to be doing 12 pegs, of which we're choosing 1, multiplied by the probability of success, which is 1 over 6 to the power of 1, times the probability of failure to the power of 11. All right, so at this point, you really need to have an understanding of what these mean. So 5 over 6 to the power of 12 is obvious. We can leave it like that. We don't, remember, we're putting it in this form, so we don't have to go and sit there and do 5 to the power of 12. That would just be ridiculous. But we do need to simplify the rest of it. So 12, choose 1. Actually, what I might do is just on this, well, obviously I'm on the side. Okay, so let's say we had n, choose 0, or n, choose n. They're actually going to be equal to each other. And there is only one possibility. So the first one, n, choose 0, that means all pegs are fine. There's no defective ones, and n, choose n means that they're all defective. So there's only really one possibility. So if you can check that on your calculator, you can do 12, choose 0 and 12, choose 12, and it's going to be 1. So you do need to remember this relationship. You also need to remember if you had 1 on the bottom, and that is the same as n over n minus 1. So if we had 12, choose 1, or 12, choose 11, we're going to have n possibilities. So for this question here, we've got 5, choose 6 to the power of 12. 12, choose 1, remember, is same as n, choose 1, which is just n, which is 12. 1 over 6 to the power of 1 is just 1 over 6. And then we've got 5 over 6 to the power of 11. All right, so you do need to go further, because remember, we need it in this form here. So if you got to this point, you've got a mark, all right? This is where it gets tricky. So I need to tidy this up, and you really need to be careful with your working. So 12 times 1 over 6 is 12 over 6, which is just 2. And then we've got 5 over 6 to the power of 11. Again, you don't need to expand those powers. It's just, you would be there for the whole SAC exam. All right, so let's take out the common factor. So as a common factor, we've got 5 over 6 to the power of 11. All right, and I'm left with the first term is just 5 over 6. Okay, so remember, if I was to multiply them two together, because they're the same base, I would add my powers to get the 12. And then I've got plus 2. All right, so I'm still going. Now the 2 I can rewrite as 12 over 6. So my answer is 17 over 6. Now, I could leave it like that. I don't think I would be penalised, but let's just get it around the way that it is. So the value of A is 17 over 6 times 5 over 6 to the power of 11. So a tricky question, understanding that you need to use how to use the binomial distribution, and also working with just manipulating your fractions and so forth to get it in this form. So if it was worth 2 marks, obviously you get 2 marks for the final answer. And the other mark would probably be here, I would say, or the next line. All right, so remember your binomial distribution. It isn't actually that hard to remember, because you've got your combinations times your probability of success times your probability of failure. All right, moving on to the 2017 exam. So in a large population of fish, the proportion of angelfish is 1 in 4. All right, let p hat be the random variable that represents the sample proportion of angelfish for sample sizes n drawn from the population. Find the smallest integer value. So remember, integer values whole numbers, and probably because we're working with angelfish, so actual living beings, such that the standard deviation of p hat is less than or equal to 1 over 100. All right, so we need to find the standard deviation. So the standard deviation formula is actually on your formula sheet. So the standard deviation of p hat is, let me just think, your probability of success times your probability of failure over n, and that's all the square root. So if we were just finding the variance, you wouldn't need the square root sign, but you do need the square root for standard deviation, and this is also on your formula sheet. Okay, so the value of p probability of success is 1/4, so 1 in 4 angelfish. Q is therefore 3/4, so not an angelfish. So basically we want p times q, which is 3/4, over n, and we're solving for n. We want that to be less than or equal to 1 on 100. So less than or equal to 1 on 100. Now all we need to do now is solve for n. All right, so I've got a square root sign there, so I'm going to square both sides. So I'm going to have, actually I might do that multiplication while we're here. So multiplying those fractions, 1 times 3 is 3, and 4 times 4 is 16. Now I'm just going to do divided by n now. I know it's not ideal to have a fraction within a fraction, but we'll deal with that in a sec. And then let's square the other side. So less than or equal to 1 over 100 all squared. All right, so 3 over 16 divided by n. Oops. Divided by n is, sorry, I might just do times. It's reciprocal, so times 1 over n. Is less than or equal to, sorry, I was just thinking 1 squared is 1, and 100 squared is 10,000. Let's just keep going. All right, so I'm going to get rid of the 3 on 16 for now. So to get rid of that, multiply by its reciprocal. So I wanted to do that in a different color. So 16 on 3 times that will get rid of the 3 on 16. All right, so they go, and then we're left with 1 on n is less than or equal to 16 on 30,000. All right, so let's take the reciprocal of both sides because I want just n on its own. So when I do that, we do need to change the inequality sign. So that's going to be 30,000 on 16. Now I should now divide through 16 into 30,000. Oops, I was doing that over here. I thought I had already done 16 over 13,000. So 30,000 divided by 16. All right, so divide 16 into 30,000. What you can do is make it easier for yourself just by simplifying this fraction. So I'm going to halve it first. Actually, you can take out the highest common factor, which isn't necessarily 2, but because we're working with such high numbers, sometimes it's easier to just keep halving it. So we've got 30,000, so I'm going to change that to 15,000 over 8. And then I'm going to change that to 7,500 over 4. And then I'm going to divide by 2 again. So 3750 over 2. And then that's a lot easier to deal with. So n is greater than or equal to 3750 over 2, which you can easily do. So n is greater than or equal to 30, what is that going to be? 1875? So the smallest integer value is 1875. So you can leave it like that. That would be fine to have the answer there. But the smallest value is 1875. This is a tricky question. It is, what, 2 marks, I think? All right, so probably just setting up the standard deviation first and then solving for n. So n is a bit hard to solve for because you're working with that 30,000 over 16, but just to simplify it, you can find the highest common factor. So you might say 16 does go into 30,000, or you can just keep halving them like I did, which sometimes I think is a lot easier to do. All right, so 1875. So quite a tricky question, that one. All right, let's move on to, okay, so now we've got some multiple choice questions. So 2017 exam 2. All right, so for random samples of 5 Australians, p hat is the random variable that represents the proportion who live in a capital city. Given that the probability that the proportion is equal to 0 is equal to 1 over 243, then the probability that the proportion is greater than 0.6, correct to 4 decimal places is. Okay, so we can identify a few things in this question. So let me just highlight them. Okay, so we've got, I was trying to look for a value of n. So we're using the binomial distribution. So n is the number in our sample, which is 5, but we don't know the value of p. But we do know the proportion of the population that is 0, okay, it doesn't say what they are, is 1 over 243. So we can represent that proportion as 0 times 5, which is just 0. So the probability that x equals 0 is 5 choose 0 times the probability of p, which we don't know, but that's going to be to the power of 0, times q. Now remember, q is also 1 minus p. So I can just put 1 minus p here to the power of 5. Now, this is all equal to, I should put a times in there, 1 over 243. All right, it was given to us in the question. So that is equal to 1 over 243. All right, so we can put that into our calculator. Just move that over a little bit. So we can just go to solve. And you can put in 5 choose 0, but if you already know that's going to be 1, you can just do that. But 5 choose 0 on your calculator, you go advanced NCR. So we're going 5, 0. And then we're multiplying it by p to the power of 0. So anything to the power of 0 is just 1. But if you're not sure of that, you can just do x to the power of 0. And then we're going to be doing times 1 minus p, or 1 minus x on my calculator, to the power of 5. And that is equal to 1 over 243. And we're solving. Remember, we're solving for x on my calculator, but don't forget you should be writing p. I'm just being a little bit lazy. All right, so this is the value of p. It's not your answer. So p is equal to 2/3. All right, and what it wants to find out is the probability that the proportion is greater than 0.6. So if we're looking at 5 Australians, so X is the number and 0.6 is your proportion. So the proportion of the 5, so 0.6 times 5. Let me just do that on the calculator. So we've got 3. So then we do the binomial distribution again. So this time our value of n is 5. We want to find the probability that x is greater than 3. So n is equal to 5, p is equal to 2/3, which we found out before, your lower limit, and we need an upper limit. Now remember, when we're doing binomial, we're using discrete values. So if we're greater than 3, we need to go from 4 up to 5. Okay, so your lower limit is 4, your upper limit is 5. So it's a good idea to write it out so you don't accidentally put 3 into your calculator. All right, interactive, discrete, binomial, CDF. So your lower limit is 4. Your upper limit is 5, the number of trials is 5, and the probability of success, do type it in as a fraction. All right, so it's 0.4609. All right, so the answer is C. All right, question 19 was taken from the 2019 Northern Hemisphere exam. So NHT means Northern Hemisphere Timetable Exam 2. So exactly the same content, they just do it on the Northern Hemisphere timetable. So they have their exams in June. All right, so a random sample of computer users was surveyed about whether the users had played a particular computer game. An approximate 95% confidence interval for the proportion of computer users who had played this game was calculated from this random sample to be 0.668, 0.8147. The number of computer users in this sample is closest to. Now, you actually have this on your formula sheet. So I'm going to just get it in front of me. Right down the bottom where it says sample proportions, so the approximate confidence interval. So I'm just going to write this down. Actually, I might pause and write it. All right, now for this one, we do know that we've got 95% confidence interval. So when you've got 95% confidence interval, let me just go to my notes here. You can see that your value of Z is 1.96. So I'm going to substitute that in. All right, so, and then basically we've got the standard deviation here. So we can set up two equations. So p hat minus 1.96, because we're doing 95% confidence interval, so it's always going to be 1.96 for 95%, over p hat 1 minus p hat over n, and that is equal to this first value, so 0.6668, and then we can use the other one, so p hat plus 1.96, and then our standard deviation. I'll quickly write that. And then what we can do is just do solve on the calculator. So we're going to have two equations. Let me just find the one that we need. I never usually do it this way. Let me just make sure I've got the right bottom. Is it this one? Yeah. Okay, so I'm going to use P and N, not like I did before, just so I don't get my values mixed up. So P minus 1.96 times the square root and then I've got p times 1 minus p over n, and that is equal to, oops, just make sure your cursor is outside that square root sign, 0.668, and I can just highlight that again and just change that to a plus, and that is equal to 0.8147. And we're solving for p and n, so p comma n, and I don't want the exact value, so let's just change it to decimal. All right, so n equals 714 times p, oh, so we're gonna have to work that out. All right, so let's just bring that value down. I don't know why it's done it like that, times p you know why? I think because I didn't put a multiplication sign in between here. Let me just go back and do that. All right, so n equals, oh, yeah, that's better. So what I just did is sometimes if you're not using x and y, the calculator doesn't like you not using multiply signs. So you can't imply there's a multiply between your p and your bracket. So I just went back and put the multiply sign in. So n is, going back to here, n is equal to 136.9. All right, you can see I'm very close to some of those answers, but I don't like guessing. Okay, so 137 is not on there. So I went back and checked where my error was. I missed out on a 6 here. Oh, how frustrating. So I'm just going to press enter again. And there we go, 134.9, which gives us the answer C. Okay, moving on. I think we've got one more multiple choice, and then there's an extended response question. All right, so another Northern Hemisphere exam question. So a box containing 20,000 marbles that are either blue or, a box contains 20,000 marbles that are either blue or red. It's a lot of marbles. There are more blue marbles than red marbles, so more blue than red. Random samples of 100 marbles are taken from the box. Each random sample is obtained by sampling with replacement. Okay, so once we take a marble out, we do put it back in. If the standard deviation of the sampling distribution for the proportion of marbles is 0.03, so that's the standard deviation of the sampling distribution, then the number of blue marbles in the box is. Okay, so let's just write down what we have. So the standard deviation is 0.03. What else do we know? We've taken a sample of 100. Okay, so if I use my equation for the standard distribution, so 0.03 is equal to the square root of p times 1 minus p, or pq, over 100. So over n, which is 100. Then we can solve for p. So we can just do that on the calculator. All right, so we need to go back to the main menu. Just go to solve, square root. Use p again, but remember to put brackets. It's probably a bit easier to type in p on my calculator, on my computer, comma p than what it is on your calculator. All right, so p equals 0 or p equals 1. Just making sure that is okay. I knew I made it. Why do I keep making mistakes? I should not do these videos late at night. Equals 0.03. I was wondering why we got 0 and 1. There we go. I'm going to just delete what I just had because as soon as I wrote 0 and 1, I was like, can't have 0 and 1. Okay, sorry. Where's my calculator? Okay, so 0.1 and 0.9. Now, it does say that we're looking for blue marbles and there's more blue marbles than red. So 0.1 means that there's 10% chance and 0.9 means there's 90% chance. So we're going to have to take P equals 0.9. So if we're wanting to know the number of blue marbles in the box, we're going to do 0.9 times 20,000. And you can do that on your calculator, but it is 18,000. All right, now this next question, so this is our last question on this sheet. We've got an extended response question from exam 2. Now, sorry, I just had to have a drink of water. Most of the questions in the exam 2 for probability will have an element of sampling in it. So you can see this question here, question 3, is worth 16 marks. And this is a very long question, so I'm just going to skip to the part where we've got the sampling in. So a supplier of laptops decides to take a sample of 100 new laptops from a number of different schools. For samples of size 100 from the population of laptops with a mean battery life of 3 hours and 10 minutes and a standard deviation of 6 minutes. P hat is the random variable of the distribution of sample proportions of laptops with battery life less than 3 hours. All right, so what we have to do is find the probability that P hat is greater than or equal to 0.06, given that P is greater than or equal to 0.05. Now, give your answer correct to 3 decimal places, but it does say do not use a normal distribution, and I'm wondering if that has anything to do with the previous questions. Let me just go back up because we do need a bit more information. The time for which a laptop will work without recharging the battery life is normally distributed with a mean of 3 hours and 10 minutes and a standard deviation of 6 minutes. Suppose that the laptops remain out of the recharging trolley for 3 hours. For any one laptop, find the probability that it will stop working by the end of the 3 hours. Give your answer correct to 4 decimal places. All right, so our mean is 3 hours and 10 minutes. So if we change everything to be in the same unit, so we should just have minutes. So 3 hours and 10 minutes is 190 minutes, and our standard deviation is 6. And we want to find the probability that X is greater than 180, so 3 hours. All right, so on our calculator, let me just grab the calculator. All right, so we're doing normal CDF because we're going greater than 180. So our lower limit is 180. Our upper limit is infinity. Let me just find infinity. There you are. You can't see my calculator, sorry. My standard deviation is 6 and the mean is 190. All right, I just realized that I did my inequality around the wrong way. So frustrating. Okay, so less than 180. So we want it to stop working by 3 hours. Okay, so let's go back to the calculator. Where are you? All right, so I'm just going to change these values. All right, so the 180 will become negative infinity. And then we're going up to 180. There we go. So 0.04, and how many decimal places? 4 decimal places. Now, when you're doing your rounding, do a few decimal places extra. So 0.04779. And then think about your rounding. So we're cutting here. And then write your answer, because if you round incorrectly, you could still get just a rounding error as opposed to getting the question wrong. All right, so we're going to use that as our value of P for question D. All right, so back to our sample. So we've got n equals 100. The probability is 0.0478, because remember, we're still doing less than 3 hours. And we've got to find our values of x. So we've got x has to be greater than or equal to 0.06. So I'm just looking at this proportion here, times 100. And x has to be greater than or equal to 0.05 times 100. So you can do that on your calculator, but that is going to be 6. And that is going to be 5. So we've got the probability that x is greater than or equal to 6, given that x is greater than or equal to 5. So a conditional probability question. So we're going to have the intersection of the two of them. So that's going to be greater than 6. So x is greater than or equal to 6 over your condition. So x is greater than 5. All right, and then we'll just do that on the calculator. Let me find the calculator again. All right, so again, we're going to be using normal CDF. All right, so for the first one, our lower limit is 6. Just make sure I've gone around the right way. To infinity. Oh, actually, can only go up to 100. So I wonder if okay. What was it? 6 and 190. Now I'm just wondering if I should have done infinity. All right, I'm going to highlight that and do 5. Okay, because then I can highlight this. I don't have to worry about e to the negative 51. It's just divided by. Oh, come on, drag down. Oh. All right, I use the normal. Oh, it even says in the question, do not use normal. Binomial CDF. Okay, so first one, our lower limit is 6, our upper limit is 100, 100, and the probability of success, now I probably shouldn't have rounded, let's use 0.04779. All right, so there's the first one. I'm just going to highlight this again and change that 6 to a 5. And then we can just highlight this divided by this. And there's our answer. So I'll just go down here. So 0, and we're doing 3 decimal places. So 657. So 658. I was going to do more decimal places, but I'm just going to round it now. So 0.658. All right, so I might leave it there because I think the rest of the questions don't relate to sampling. All right, so just showing you in their 3-mark question, let's think about how those marks would be allocated. Probably getting the x is greater than or equal to 6 and x is greater than or equal to 5. putting them into your conditional probability formula and working that correctly, and then having 0.658 as your answer. All right, I'm going to leave the video there. Otherwise, it's going to be too long if I do all of that question. So it might be a good idea to have a look at the rest of that question and attempt it on your own, and you can check your answers on the VCAA website. All right, bye.